I wanted to answer one simple question. Which of these machines can generate 1 million tokens the fastest? Here I've got my bench that I built. It's one of two, but on the other one, my motherboard broke, so we got one. With an AMD Radeon 9060 XT, some would call that a budget GPU. I also have a non-budget DGX Spark. And by the way, yeah, you don't need to point out the fact that this is not fair. Of course it's not fair, but as you'll see, it doesn't have to be in order for some of these to be better than others in certain tasks. By the way, this GPU has 16 gigs of VRAM. The DGX Spark has 128 gigs of VRAM. Another one with 128 is the Beelink GTR9. And that one has the AMD Strix Halo, the golden boy of AMD's APUs from this year. I've tested a bunch of them on the channel, and this one is actually the fastest. So that's why I included it here. And finally, the lookalike. It's an imposter. I'm just kidding, it's the other way around. But the Mac Studio, this one is the big boy, the M3 Ultra with 512 gigs of VRAM. None of the VRAM stuff matters right now because I'm gonna be testing small models. This is a race, folks. So obviously some things need to be equal, right? So they need to all fit inside the smallest common denominator, which is this 16 gigabyte GPU. And I also have access to an H200 cluster, thanks to a friend of the channel. You know who you are. And I will follow up this video with an explanation of the whole setup. I spent a lot of days putting together this test and a whole suite of benchmark tools to be able to show you not only this, but I'll make a separate video on how I built it and why it matters. And I think you're gonna be quite a bit surprised when you see that. But for now, we're having fun and just racing to 1 million. Now, first problem I ran into is what model should I use? I wanted to find something that's gonna fit into all these, which is gonna be something small, and I decided to go with Qwen 3 4B. Yeah, it's a 4 billion parameter model. These machines can easily run that, and bigger models too, of course, but this one can't, so we're gonna stick with 4B. And in some tests, I ran the BF16 version, which is the unquantized version. I think it's no surprise that Mac Studio did pretty well here, considering it has the highest bandwidth, so it's gonna generate tokens pretty quickly in llama.cpp. Here's the result for that. And this test simulates like a chatbot if there is one person talking to one instance of a model. But that's not what we're after. We're after total throughput. Notice that our little Radeon GPU, the one that's the cheapest out of all these machines, is doing pretty well in that, considering everything else. But most of the time when you're running locally like this, you're not gonna be running BF16. You're probably going to run something quantized like an 8-bit version or FP8. And the difference between FP8, which is floating point 8, and integer 8 is something I talked about in other videos. Basically, you're quantizing to 8 bits. So I'm going to compare 8 bits across all the different quantizations of 8 bits, whether it's MLX 8-bit or integer 8 or Q8 in llama.cpp world, which is integer 8, and FP8 on hardware like the NVIDIA box. But for the llama.cpp comparison, not VLLM, I used integer 8. I know, this might sound confusing. I'm gonna make another video that explains everything, but I'm just setting up the race for now, and I'm gonna go into details in the other video. Here's what it looks like with 8-bit. Q80 is the quant all across the board on all the machines. Concurrency of 1 here. M3 Ultra is doing pretty well here, and Spark is doing the worst. Does this mean that the Mac Studio is gonna win the million and the Spark is gonna lose? No, at least I don't think so. But let's find out. Fast rigs are great, but reliability comes from fundamentals. That's why I keep sharpening the basics. Meet boot.dev, the most engaging path I found into backend web development. It's like an RPG for coding, quests, XP, leaderboards, plus an integrated AI guide to help you keep going. You build in Python, Go, JavaScript, aligned with real backend work. APIs, auth, databases, testing, caching, everything that matters. There's an active Discord server, step-by-step solutions, and a job-ready curriculum. No endless theory. The best part? You can browse lessons for free. A membership unlocks interactive coding, AI help, progress, and game mechanics. I used to binge tutorials like TV shows. Fun to watch, but nothing gets shipped. Boot.dev turns learning time into shipping time. Hit the link below and use my code for 25% off your first Boot.dev payment. I'll see you in the quests. Now you can also tweak the concurrency knob, which is how many requests a machine is handling at the same time. And llama.cpp can do this up to a certain extent, but it's not its power. Here's an example of concurrency of 4. You can see the numbers are a little bit faster everywhere. 272 tokens per second on the M3 Ultra. Pretty good. 127 on the Beelink GTR9. That's the Strix Halium box. And then 136.7 on the Radeon card here. And 51.8 on the Spark. Spark, you're letting me down. A $4,000 machine.
Just hold on.
You're not actually running llama.cpp on the Spark, are you? Well, maybe you are, but you shouldn't. It's slow. You see, on NVIDIA hardware and also on AMD hardware, you can run a library called VLLM that is not only faster, but also allows you more concurrent connections. But VLLM doesn't run on Macs. MLX runs on Apple Silicon on Macs, but it doesn't run anywhere else. So we got VLLM on the AMD machines, and we have MLX on Apple Silicon. Now, I don't want to say you shouldn't run llama.cpp. It's fine if you're just doing some testing. If you just want to set up a quick server, something that's easy, especially things like llama. llama is probably the easiest thing you can install, and that's built on top of llama.cpp. One line of installation and you're off and running, and that's it. I made a separate video on how to do all that. I can link to that down below, but that's easy. VLLM, not a very easy setup. It's getting there, but it's not as easy, especially on AMD. MLX, easy enough, but for somebody who's brand new to this, not as easy as llama. Now, I think we should kick off the race before I talk too much, if that hasn't already happened. And I also want to keep an eye on the power that's being used by all these machines while we're racing, because that's going to be handy too. This is my custom bench with the Radeon machine. 53 watts being used by that box total. That's without running anything. So all the other power is being used by the rest of the components in the system. 41 being used by the Spark at idle. Quite high, I should say. 18 being used by the Beelink machine. And only about 8 or 9 watts being used by the Mac Studio. Wow. It's a big range. I'm gonna kick off VLLM on 3 of these and MLX on the other one. This is my bench. This is the Beelink machine. This is the Spark, and this one is the Mac Studio. VLLM takes a while to start up, but like maybe up to a minute, sometimes 2. MLX starts up right away, but startup time is not something we're counting in this race, is it? This is the tool I created for this race. It's a CLI. It also has a couple of other sweeps that I'll go into in the next video to find the optimal for all these machines. I'll probably publish this and link to it in my GitHub. If you're interested, let me know in the comments down below. So here I have a bunch of different configurations for the race. Here's one for the Beelink GTR9, Quen34B, and I'm setting this to be target 1 million tokens. Oh yeah. Max tokens and concurrency is something I'll go into the next video. Suffice to say for now that that is the optimal sweet spot I found based on a bunch of sweeps I did ahead of this video. Yeah, it took me like a week to prepare for this. And then I have a couple of servers that are serving this. So here are the configurations for these. Also access to the B200s. I'll maybe save that for another video. I have H200s, Beelink, the Bench, M3 Ultra, and Spark. And I did also try this when I was developing on this machine. This is the M4 Max, my daily driver. I just made a video about this. That's a side note. Side note goes in this camera. Unrelated, but you can watch that video too. I've been working on this machine for over a year now. Servers are started. Here are my clients, and I run it like this. Bench CTL, command race, and then we pass in the config, MS, M3 Ultra, 8-bit MLX. And then we pass in the environment, which happens to be MS. I should probably tweak that to be more streamlined, but that's what I got for now. All right, we're ready to go. Now, before I do that, I want to reset these counters so we can see the total cost, the total wattage that's been used while the test is going on. I'm setting the cost to be 20 cents. Could be expensive, could be not, depends where you live, but I'm setting it to be 20 cents per kilowatt hour on all these. I think we're ready to go. Boom, 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 and boom. Great. I made a CLI and I forgot to pass in a flag. All right. You know what they say, when you vibe code something, you probably don't know how it actually works. Hey, I'll admit it. All right, boom, 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 and boom. Here we go. This is fun. Oh, did you hear that? And I gotta say, even though this thing is really loud, it's definitely the loudest machine in here on my desk, and it's the loudest Strix Halo machine I've ever tested. It's not even, I mean, it's a little bit warm to the touch, but the cooling on it is pretty good at the expense of being loud. Whereas the Mac Studio, it's quieter, but it's definitely really warm on top. And just to show you on the server side, we're actually getting all these requests. And before I show you the results, I want you to actually write down your comments. Who do you think is gonna win this one? But don't cheat, really guess which one do you think is gonna win. Hey, challenge yourself, come on. You should have an open mind and maybe not necessarily go by what you've seen online already, because it may be wrong. Hey, this may be wrong too. It's a video on YouTube. This is the bench, 267 watts being used wireless processing. This is the DGX Spark 143, E-Link machine 153. And here's the Mac Studio usage while it's fully utilized and running. VLLM is working quite nicely on this Strix Halo box. Look at that GPU go. We've got 100% utilization, really nice memory utilization there too. Here's the Mac Studio utilization with MLX. There's 100% usage, but it keeps going down and then restarting. Of course, we have a 512 gigabytes of RAM available here for running models. It's a little bit less than that, but it's close. It's enough. I mean, that's a heck of a lot. We're using about 46 of that for what we're doing right now. Now, the way I'm running this race is I'm sending out a bunch of requests. They get fulfilled, they get returned, and then we do it again until we get to 1 million tokens. And this is the same for all of them.
Why would you do such a silly thing, Alex?
Because we're kind of moving beyond the one-on-one conversation with a chatbot. The way you actually work with machines like this in the real world with power that's available to you is you'd set it up in your office, for example, as a business to have multiple people connect to the machines at the same time and use them like that. Or you would use them with an agent or as a coding assistant. For my workflows, I used it to create a script that would automate creation of sound effects in some of my videos. I know you find that annoying sometimes, but hey, I don't use them very often, but I find key moments where I want to insert a sound effect and I shoot off multiple agents to go ahead and find these spots for me, talk to different models and insert the sound effects. It's actually pretty cool, I think so. But there's a lot of cases where you'd have multiple agents working concurrently, talking to either the same model like we have in this case or multiple different models. And the hardware is fully capable of handling that, but what's not always capable of handling that is software. NVIDIA has been working on this for a long time, and that's one of the reasons why the Spark exists, is so that you can kind of simulate those kinds of workflows on your desk. And I think a lot of people miss that. Now, llama.cpp is the complete opposite. You can set it up for a lot of concurrency, and I'm planning on doing a video on that as well. Hang on for that one, that's going to be interesting. But as for llama.cpp as a server running on its own, it's not super helpful for concurrency. And that's why the throughput for llama.cpp is so much less than for other tools like VLLM and even MLX. So we've got our results, folks, and it's interesting, not at all what I expected, especially this one. All right. So first of all, we know that the Mac Studio is super efficient when it's sitting there idle. I mean, it's efficient in general, right? And after I calculated how much energy these tests burned on each machine, let's say we have the idle equivalent runtime. Let's say they were just sitting idly. This is how long each machine would need to use up that energy. So you can see that the Mac Studio would take 5.67 hours sitting idly, what we just did in, I don't know, in a matter of a few minutes. Beeling GTR9, the Strix Halo machine, also pretty good. But the bench with the Radeon card in there and the DGX Spark, not so much. Less than an hour for each one of them. DGX Spark sitting idly is not a good use of energy. You need to be using that thing. And if you're using it, then it really pays the bills. Let's check that out. You remember in the beginning, I measured the idle wattage? Well, here's that. Mac Studio using only 9, my bench using 54. I subtracted that from when it was actually active. And the total energy in kilowatt hours while generating the 1 million tokens, well, you can see for yourself that the DGX Spark used the least amount of energy while generating the 1 million tokens. The most? The Beeling GTR9. I told you were gonna be surprised. I told you were going to be surprised. How the heck did this happen? Well, we'll get to the times in a moment. So if we estimate 20 cents per kilowatt hour, here would be your costs for this particular generation. You can extrapolate that to whatever workload you're running. Finally, tokens per kilowatt hour is an interesting one. And DJX Spark delivers more than 2 times of the runner-up, which is the Radeon card. So who was the fastest? Well, it was not the Mac Studio that was actually really good at llama.cpp. It took, well, I guess more than a couple minutes, almost 26 minutes for the Mac Studio to crank out 1 million tokens. But that wasn't the slowest one. The slowest one was that Strix Halo machine, and that took 34 minutes. Wow, I guess I must have been having fun while I was waiting for this, because time flew. Not really. But you know what was fun to watch? The Spark at work. Actually, the budget Radeon card did really well here. I'm really surprised. I'm praising the Spark a lot, but I gotta consider that that is a $4,000 machine, whereas the Radeon card and this whole bench you can probably build for $1,000, maybe $1,500 now with the RAM prices. The Radeon card ran this in 8.5 minutes. For a total of 1,913 tokens per second generated. Finally, the Spark took 6.7 minutes to do the whole thing, and it is our winner for the fastest at 2,451 tokens per second. That's some crazy throughput. All right, now just for the fun of it, let's run a model on the H200 cluster. 8 H200s. 4 billion parameter model is like driving a Lamborghini on city streets. Let's give it something bigger to chew on. A 480 billion parameter Qwen3 coder model. And we're gonna go to 1 million tokens. Well, since we're just having fun, I'll use a much larger model, which would not even run on most of these. Let's go. Oh, and there it goes. Look at those tokens being generated. We're up to 50,000 tokens already. 100,000. By the way, I'm running this on Scale servers, and I was told this can go way faster than I'm running it. Unfortunately, I'm still a noob at running these in the cloud professionally. There are ways to optimize this even more. I'm just impressed by all the tokens I'm getting and how fast. And I will be digging more into this and running things faster on all this hardware, so make sure you don't miss that stuff. One thing I can't see though is how much power is being used, but you can imagine that it's probably a lot. But you can kind of guess based on the fact that there's 7 H200s, each one is capable of 700 watts, and we're using almost all the watts. Oh yeah, each card also has 140 gigs of VRAM. Yeah, 383 seconds. That's like 6.3 minutes. Why is it so slow? Oh, because we're not running Qwen3 4 billion, we're running 480 billion. Furthermore, this is BF16. This is not some quant. And it ran this faster to 1 million than the Spark ran the Q4 to 1 million. 2,609 tokens per second. Nice. So this was a fun one. Stay tuned for that other video where I'm gonna go into the details of how I did what. And yeah. Subscribe to the channel if you're not already. Talk to you later. Bye.